All right, so our goal for this, well, it'll take us 2 or 3 weeks, is to learn how to write chemical formulas. In order to do that, we need to understand fundamentally what does an atom look like. So our two targets for today, I can describe and apply terms isotope, atomic number, and mass number. I can use and interpret the nuclear symbol to determine the number of protons, electrons, and neutrons in an atom or ion. So yes, I understand. Most of that is just gibberish. By the end of this lecture, it will not. What are nucleons? That sounds almost like it's some kind of alien creature from Star Trek, doesn't it? The nucleons are coming. The nucleons are coming. Well, it's nothing that exotic. It is simply the particles that make up the protons and, the particles that make up the nucleus. The particles that make up the nucleus. And what are the two types of nucleons, since you've known this since middle school? What are they? Can somebody raise their hand and tell me one of them? Really? You didn't go to middle school? Yes, Alex. Electrons are most definitely not a nucleon. Protons is a nucleon, and neutrons. No. Once again, electrons live outside of the nucleus. They're orbiting the great planet Nucleon. So nucleons are made up of these yellow little balls called protons and orange little balls called neutrons. Them are the nucleons. So, since Uni brought it up, what are protons? Positive particles that live in the nucleus. The positive particles that live in the nucleus. What are neutrons? The other particle that lives in the nucleus, it is neither positive nor negative. It is neutral. So the little positive ones are protons. The little neutral ones are neutrons. Casey, why are you giving me the evil eye? Where is most of the mass of the atom found? Okay, so it's late October. Your parents have had a pumpkin out in their front yard, decorating it for quite some time. By this time, you walk by and you go, ew. And then you look carefully, and on this big giant pumpkin, there's these little gnats. Little fruit flies. Gnats. Okay? Then you look and you go, oh, it's full of gnats. So you run home and you tell your mom, I think the pumpkin's gone bad. And then your mom says, grab a bag, a trash bag, put it in there. And you go, no, I don't want to touch it. And she goes, do it. Just do it. All right? So you go and you put it in there. Okay. You want to know the relative sizes between what's inside the nucleus and what's outside the nucleus. You need to keep that in mind. A big, nice size pumpkin is a proton or a neutron. That's about the size relative to the gnat. The gnat is an electron. So the gnats live outside the nucleus. So can we not believe that most of the mass of an atom comes from the nucleus? The electrons live outside and they're little bitty. They hardly have any mass. They're about the difference between a gnat and a pumpkin. or a gnat, and a watermelon. A watermelon. Compare a gnat. Do you see a G there, Dalen? Yes, there's a G there. Why would there be a G there? Then why even have a G there? Okay, you know, the deer-like creature that lives in Africa, a gnu. It's not a new, it's a gnu. So why can't this be a gnat? That's why I'm telling you it's a gnat. So compare a gnat to a large pumpkin, and now you have the difference in sizes. I say that if we don't use in the English language, and you Spanish speaking people like Oscar, you would appreciate this, you would understand. In the English, if you English primary English speaking people want us to learn English as well as you do, then any word that does not have a letter that you pronounce, get rid of that letter. All right. So the nucleons are going to have protons and neutrons, and outside are going to be covering the gnats. What is the only thing that distinguishes one atom from another? Number of protons. For example, look at Alex and Oscar. They might as well be identical twins. They look the same to me. Okay? What is the difference between them? Social Security number. Social Security number. So everyone on this country, in this country, has a different Social Security number, and if you don't, then somebody stole your identity, and you might want to do something about that. Okay, so your Social Security number is unique to you. No one else has your Social Security number. In the same way, all elements have their own unique Social Security number. That is the number of protons. So if you have 6 protons, then you have to be carbon. You have to be, because only carbon has 6 protons. So how do you find out the Social Security number of all the different elements? By finding its atomic number. Atomic number. What is atomic number? It is the number of protons. So number of protons, atomic number. Atomic number, number of protons. Why do I keep saying number? Because the symbol for atomic number is Z. Now you may ask, Mr. Marino, why isn't it A for atomic? Because when they discovered protons, atomic had already been taken up. A had already been taken up. So sorry, can't use A. Well, what about N? Oh, by the time they discovered protons, N had already been taken up. So we were down to the letter Z. So I pronounce it atomic number to remind me that the symbol for atomic number is Z. So where can you find atomic number on the periodic table? It will always be found on top of the symbol. It is the whole number that is on top of the symbol, not the fraction that's down at the bottom. That's the atomic weight or the atomic mass. We're talking about the whole number that is on top of the symbol. The whole number that's on top of the symbol. So why is this oxygen? Because of that 8. What is 8? Oxygen. See how this works? So atomic number is the number of protons, the H is the symbol, the name, and the atomic mass. We'll cover atomic mass soon enough. Using the periodic table, determine the atomic number for the following atoms. Are you ready, Sean Denisovich? Ready? Fe. Good. What is its atomic number? What is its social security number? You need your periodic table, which should be out, of course.
Oh my God. I think I know.
Jonathan is doing this one. 26. Uranium. Ariel. Uranium. Where's your periodic table? How would you know this? You kind of lost it. That's kind of bad. So walk over here, grab one, and find uranium. Let's go quickly. While you're doing that, we're going to go on to Na. Let's see. Daylin, 11. Iodine, Matthew, 53. All right, look for it down at the bottom. Look for you down at the bottom, Ariel. 92. Excellent. All right. So let us talk about the difference between identical twins and fraternal twins.
I know.
Go. Not personalities.
No.
Okay, no. She's half right. Halfway. Okay, she is half right. Go. Now, sometimes fraternal can actually look the same as well. Not identical, but okay, here's the difference. In identical twins, you start out with one egg and one sperm, and they meet and they become a zygote. And at some point, that clump of cells divide and split off into two. So where you had one person, now you have two. Caden and Jameson Upgraft are examples of identical twins in that they have almost the same DNA. Now, why is it almost the same DNA? Because as soon as they start growing, every time a cell divides, every once in a while, there's a mistake. So they are 16, 17 years old. After 16 or 17 years old, their DNA is no longer 100% the same. It is now 99.9999999% the same. But, I mean, they're pretty dang close. Okay? Fraternal twins start out with two eggs and two sperm. The Askan sisters are fraternal. Okay? So her mom released 3 eggs. Dad contributed 3 sperm. So bam, bam, bam. You got 3 different people, which look similar, but they look similar as brothers or sisters would look similar, right? Okay, so let's throw away the whole fraternal thing. That doesn't work for us. Identical does work for us. Isotopes are elemental twins. They're like identical twins. They have the same number of protons, different number of neutrons. Nope.